Hello everyone, myself Hans. Today we are going to solve the given problem based on Jacobian. Here in the question, if x is equal to u and y is equal to u tan v and z is equal to w, then we have to show that del of x comma y comma z upon del of u comma v comma w into del of u comma v comma w upon del of x comma y comma z is equal to 1. Let's solve the problem. Here given x is equal to u and y is equal to u tan v and z is equal to w, and we have to show that is del of x comma y comma z upon del of u comma v comma w into del of u comma v comma w upon del of x comma y comma z is equal to 1. We have to take, let this equation 1, and taking left hand side, taking LHS, that is del of x comma y comma z upon del of u comma v comma w into del of u comma v comma w upon del of x comma y comma z. We have to find the value that is given by the determinant. First, that is, we have to given del x, del of x y comma z upon del of u comma v comma w is given by del x upon u and del y upon u and del z upon u. Further, we have to write that is del x upon v and del v and del y upon del v and del z upon del v. Further, for third, that is del x upon del w and del y upon del w and del z upon del w. For second, that is del of u comma v comma w upon del of x comma y comma z is given by del u upon del x, del u upon del x, del v upon del x and del w upon del x. For second function, that is del u upon del u upon del y and del v upon del y and del w upon del y. For the third, that is del w, once again uvw, we have to write that is del u upon del z and del v upon del z and del w upon del z. We have to find the value of these and we have to put in the determinant. Further, we have to solve the determinant. First, we have to find del x upon del u, del x upon del u, differentiating x is equal to u with respect to u, that is 1. Further, we have to find del x upon del v, del x upon del v, x is equal to u differentiating partially with respect to v, that is 0. Here is not present the coefficient of v. And further, we have to find del x upon del w, Here is also the coefficient of w is not present, so we have to write del x upon del w is 0. Further we have to find del y upon del u, del y upon del u, that is y is equal to u tan v differentiating partially with respect to u, that is tan v, and del y upon del v, we have to differentiate partially with respect to v, that is u tan differentiating tan v with respect to v, that is sec square v. Further we have to find del y upon del w. Here in the y is equal to u tan v, here is not coefficient of w, so we have to del y upon del w is 0. Further we have to find del z upon del u, differentiating z is equal to w with respect to u, that is 0, here is not coefficient of u. Further we have to find del z upon del v, again differentiating z is equal to w with respect to v, that is v is not present, so we have to write 0, and del z upon del w, again differentiating z is equal to w with respect to w, that is 1. Putting the value in the above determinant, that is del x upon del u is 1, and del x upon del v is 0, and del x upon del w is also 0. Del y upon del u is tan v, and del y upon del v is u sec square v, and del y upon del w is 0. Further we have to write del z upon del u, that is 0, and del z upon del v is also 0, and del z upon del w is 1. Further we have to find the second determinant value. We can find the value of second determinant, that is we have to find del u upon del x. We have to first write, that is the given value, that is u is equal to x, and here is v is equal to, that is tan v is equal to y by u, and w is equal to z, and from here we have to put the value of u is equal to x in the second, that is tan v is equal to y upon x. Then we have to find del u upon del x, that is del u upon del x, u is equal to x differentiating partially with respect to x, that is 1. Further we have to find del u upon del y, u is equal to x differentiating partially with respect to y, there is not present y, so we have to write 0. And further we have to find del u upon del z, this is also 0 because here is not present a coefficient of z. Further we have to find del v upon del x, that is differentiating tan v with respect to del v upon del x, that is sec square v, and del v upon del x. Further we have to differentiate partially with respect to x, that is y by x is, y is taking constant, and 1 upon x is differentiating partially with respect to x, that is minus of 1 upon x square. Further we have to write, that is del v upon del x and minus of y upon x square, and sec square v is taken into denominator of x square, and sec square v is written as 1 plus tan square v, and we have to put the value, that is minus of y upon x square and 1 plus tan square v. Then from here, that is the value of tan v is y upon x, that is 1 plus of y square upon x square. Further we have to solve, that is minus of y upon x square, and taking LCM here, that is x square plus of y square upon x square. X square to x square is cancelled out. Then the value of del v upon del x is minus of y upon x square plus of y square. Further we have to find del v upon del x, del v upon del y. We have to find once again del v upon del y. Del v upon del y, differentiating tan v. Once again, del v upon del y, that is tan v differentiating, that is sec square v, and del v upon del y is equal to 1 x is taken constant and differentiating y with respect to y, that is 1 upon x. From here we can also write, that is del v upon del y is equal to sec square v is taken into denominator of x, that is 1 upon x, and sec square v is written as 1 plus of tan square v, and putting the value of tan v, that is del v upon del y is equal to 1 upon x, and 1 plus of the value of tan v is y by x, that is y square upon x square. Further we have to solve once again. Further we have to solve. Further we have to solve, that is del v upon del y is equal to, taking LCM here, that is 1 upon x and x square plus of y square upon x square. From x square to x is cancelled, remaining is del v upon del y is given by x upon x square plus of y square. Further we have to find del v upon del z. Here is the coefficient of tan v is equal to y upon x, then coefficient of z is not present, so we have to write del v upon del z is 0. Further we have to find del w upon del x. Del w upon del x, here is the coefficient of x is not present, so we have to write del w upon del x is 0, and del w upon del y, here is also the coefficient of y is not present, so we have to write del w upon del y is also 0, and further we have to find del w upon del z. Del w upon del z, that is 1. Put in the value of the above determinant, that is del u upon del x is 1, and del u upon del y is 0, and del u upon del z is also 0. Further, del v upon del x is given by minus of y upon x square plus of y square, and del v upon del y is given by x upon x square plus of y square, and del w upon del z once again, del v upon del y and del v upon del z. Del v upon del z is given by 0, and del w upon del x is also 0, and del w upon del y is also 0, and del w upon del z is 1. Further we have to solve the given determinant. Further, we have to solve the given determinant, that is on open this then these term and this term is cancel out, then squaring both the side, that is on cross multiplication, that is u sec square v, and on cross multiplication with this, that is 0, then the value of first determinant is u sec square v. And further we have to, from here we have to also neglect this, and we have to multiply cross multiplication with, that is x upon x square plus y square, and again cross multiplication with 0, that is 0, then the remaining is x upon u sec square v. We have to put the value of, u, that is the value of u is x, and sec square v is written as tan square v, 1 plus of tan square v, and into of x upon x square plus of y square, and we have to put the value of tan square v, that from here, that is tan v is equal to y by u, and here we have to put the value of u, that is y upon x. We have to put here, that is x into 1 plus of, in place of tan v we have to put y by x, that is y square upon x square into x upon x square plus of y square. From here we have to write x into x is x square, and taking LCM, that is x square plus of y square upon x square into of 1 upon x square plus of y square. From here x square plus y square to x square plus y square is cancelled out, and x square to x square is cancelled out, then the remaining answer is 1. So we have to prove the right hand side 1. So we have to set del of xyz upon del of u comma v comma w multiply with the del of u comma v comma w upon del of x comma y comma z is equal to 1. We have to find the right hand side, that is RHS. So we have to say LHS is equal to RHS. We can also write in this form, that is we can also write, that is del of x comma y comma z upon del of u comma v comma w into del of u comma v comma w upon del of x comma y comma z is equal to 1. We have to prove LHS is equal to RHS. Thank you class, and thank you for watching.